All right, so we've got angles related to a circle, and if you want to follow along, you can do so right here. Let me switch over to pen mode real quick. Okay, we have a bunch of objectives, so let's get right to them. All right, first one, you will be able to determine the measures of central angles. You'll be able to determine the measures of inscribed angles. You'll be able to determine the measures of inscribed and tangent chord angles. You'll be able to determine the measure of chord angles. And finally, you'll be able to determine the measures of secant, secant-tangent, and tangent-tangent angles. And you're probably looking at this saying, oh my God, this video is going to be like 45 minutes long. What am I going to do? How am I going to remember this? I'll try and teach you an easy way. Don't worry. All right, so let's start with angles with vertices in the center of a circle. This part's going to be a review. Remember that the measure of a central angle and its intercepted arc are equal. So say we have this circle, circle O, and we have arc AB equals 50. Well, if arc AB equals 50, then angle O also has to equal 50, and vice versa. Okay, so that's an easy one. Let's go a little bit harder. Angles with vertices on a circle. Again, this should be a review to some degree. So first we have inscribed angle, and that's an angle whose vertex is on a circle and whose sides are determined by two chords. So here we have our circle. We've got points B, A, and C. B is the vertex for chords AB and BC. And then you also have tangent chord angle, which is similar. It's an angle whose vertex is on a circle and whose sides are determined by a tangent and a chord that intersect at the tangent's point of contact. All right, so that's this here. Now they look really different, but the key to remember for all of this is look at where the vertex is. Vertex is on the circle. Vertex is on the circle. So that means that, let's say this was angle X, this arc measure would be twice that. Okay, same here. We don't have an arc measure. At least it doesn't look like we do, but we in fact do. This one here. So this arc measure, ST, would be the double of that. So even though that one's not as obvious, that's why I say look at where the vertex is. If the vertex is on the circle, the angle is half the arc measure. Okay? So please, please keep that in mind. So a good example would be if this arc here, let me get rid of the ink for you. So let's say this arc here, ST, equaled, let's say 100 degrees. Okay, that would mean that angle T would equal 50 degrees. So hopefully that makes sense. So this arc here would be 100. This angle would be half that at 50. The flip side of that is, let's say I said that this angle here was 20 degrees. That would mean that this arc measure would have to be 40 degrees because it would be, again, twice that. If I said this was 40, then you half it. So if it's the arc measure they give you, then you half it. If it's the angle measure, then you double it. Okay, so please, I know I didn't write that down on here, but hopefully you are writing that down and not just copying down what's on the screen. You're actually writing my words down. All right, so let's start. Let's go on to angles with vertices inside, but not at the center of a circle. Okay, we have a chord angle, and that's an angle formed by two chords that intersect inside the circle, but not at the center, such as this. Okay, so it's inside, but not at the center. And what we do here is we go to Theorem 87, which states that the measure of a chord angle is 1/2 the sum of the measures of the arcs intercepted by the chord angle and its vertical angle. All right, so let's say that here you have angle 1. Okay, how do we figure that out? Well, you take the measures of the arcs that the two chords create, CD and EF, you add them together, easy enough, and then you just divide by 2 basically. So you'd add the arc measure of EF and CD, divide by 2, that would give you the measure of angle 1, And let's say I call this angle x, that would be also the same measure because they're vertical angles and vertical angles are congruent. So remember, inside the circle, add the arcs, divide by 2. So that's an easy way to remember that, which takes me to the next one, angles with vertices outside a circle. So there's a few of these. Secant angle is the first. As you can see there, vertex is outside the circle. And we've got 2 segments that cut through the circle, not through the center or anything like that. Okay, and that's an angle whose vertex is outside a circle and whose sides are determined by 2 secants. Okay, meaning they pass through the circle twice. Okay, you also have a secant tangent angle, as you can see here. Okay, again, vertex is outside the circle. And that's an angle whose vertex is outside the circle and whose sides are determined by a secant, that's this one here, and a tangent. This one here never actually goes into the circle, it just touches it. I'd say right about there. If I was to continue it on, it'd go like that. And finally, there's tangent angle, which is this. And again, notice that vertex is outside the circle. And these never actually cut inside, but they do touch the circle. And that's an angle whose vertex is outside a circle and whose sides are determined by 2 tangents. All right, and these all fall under Theorem 88. And that's the measure of a secant angle, a secant tangent angle, or a tangent angle. These are all vertex outside the circle, is 1/2 the difference of the measures of the intercepted arcs. So basically you take the circle, and if you subtracted the 2 arcs that were created from that circle and divided by 2, you would have the measure of that angle that's outside the circle. Okay, so hopefully that makes sense. Remember, inside the circle, you add the arcs. If there's, the 2 chords not at the center, you just add the arcs, divide by 2. If the vertex is outside the circle, you subtract the arcs, divide by 2. And then the central angles and the angles on the perimeter of the circle should be a little bit easier to figure it out and remember. Okay, so there you go. You have an example of what I mean. You take the smaller one, subtract it from the bigger one, divide by 2, and that'll give you this angle here. Okay, so let's actually try some practice problems. So we need to find the measure of arc EF and the measure of arc CD. And we're given that this is 65 degrees, and this is 24 degrees, and this is not at the center of the circle, okay? Should be obvious from looking at it, but I'm just letting you know that. So let's say that the measure of EF is X, and the measure of CD is Y. We can then say that 1/2 of X plus Y equals 65, okay? Because remember, inside the circle, we add the 2 arcs, divide by 2, and 1/2 the difference of the arcs, X and Y, equals 24 because this vertex is outside the circle. So then if you get the variables on one side by themselves, you get X plus Y equals 130. Well, just in case you don't see how I did that, if I have 1/2 X plus Y equals 65, okay, I have to multiply by 2 to get rid of that on that side. Since I did that over there, I have to do it to the other side as well, which gives me X plus Y equals 130. Same thing with this here. If I have 1/2 times X minus Y, and that equals 24, I'm still multiplying by 2 to get rid of that, and I can get X minus Y equals 48. So if you don't understand how I did it, there you go. And then we set up a system. But the good thing about these systems is that they're actually, you don't have to do a whole lot of craziness with them. You just add them together because chances are you're going to have one that'll cancel out. So X plus Y equals 130, and then you add X minus Y equals 48, and just add them in the columns like this. And you're going to get 2X equals 178. So X equals 89. So we know that this arc measure here is 89 degrees. Then we can just go back, plug in your x, plug it into the first one, or it doesn't matter which one you do, but let's plug it into the first one. And we have 89 plus y equals 130. Subtract 89 from both sides, and you'll get y equals 41 degrees. See how easy that was? Thus, the measure of angle of arc EF equals 89, and the measure of arc CD equals 41. Let's try one more problem. So you had a problem like this before, but this one's a little bit different. So you're given angle DCE. I think it should be DCF. DCF equals 25 degrees. And that CD and FD are congruent. We need to find the measure of angle X. So if DCE, oh, I read that wrong. It was DCE. Sorry, it's late right now. So DCE is 25 degrees. So if DCE is 25 degrees, and remember, this is on the circle, so whatever that arc is double the angle, so that means that DE equals 50 degrees. Okay, and that means because this goes through the center of the circle, this is a semicircle. So that means that this whole thing has to be 180, and if this is 50, this has got to be 130. Okay, because it's got to equal 180. And since CD and DF are congruent, this arc is 130 as well. Okay, because remember about congruent chords and congruent arcs, thinking back a little bit. So if DF is 130, 130 minus 50 is 80. So we can say that that's going to be 80. Okay, as you can see by my steps there. So, but they're asking for the measure of angle X. So now what do? Well, we can find X by our formula because it's inside the circle, not at the center. So we take the measure of the arcs. We've got 130 over here and 80 over here, and we add them together. 130 plus 80 is 220. Actually, it's 210. Told you it was late. 210 divided by 2 is not 110. It's 105. Everyone makes mistakes. Ah, get out of here. Everyone makes mistakes. All right, so the measure of angle X is 105 degrees. That's our answer. All right. That should just about do it. And this was a longer video, I know. So I had this little message for you guys. Yes, it is over. And I thought it wouldn't end. And I thought of this when I finally did reach the end. Enjoy the rest of the videos for this week. Have a good night.